Hi everyone, very good morning. I hope all of you very well and happy today. Yeah, so I just came with today with new topic, and this is very important and crucial topic of the computer science programming actually. That is the recursion. So there are few things we solve very large problems using this recursion. Yeah. So let's start. As you can see on my screen, there is a diagram we are showing here actually regarding that recursion, and this is very simple example I just created over here for the for you for solving the problem using the recursion technique actually. Okay, so this is very simple diagram. So we are solving here the Fibonacci. So first we have to know what is the Fibonacci. It is a series actually that is consecutively print like 0 1 1 2 3. So what is happening here, when it is 0 1, then 0 plus 1 is equal to 1, then the next one will print, then 1 plus 1 will be 1, then the 2 will print, so like that. So let's talk about this something. So here it is happening. So we are using the, if you see right here this box, so this is something our program stack, and where our code is resided code actually code block. So Fibonacci method is there, and we are executing this logic: c is equal to a plus b, a is equal to b, and b is equal to c. So c is equal to a plus b, it is adding the previous number and predicting the c what will be the next number, right? And it will print. So this keep continue until your n becomes 0. So when your n becomes 0, it will exit. Otherwise, if it is not getting 0, it will call again n minus 1 using. Okay, so I think you got this particular diagram. uh, I hope all of you understand. कभी कभी हम हिंदी में भी बात करेंगे इसमें, ठीक है, क्योंकि मैं बिकॉज many peoples uh, will confuse, and for more clarity we will talk about in Hindi. Okay, yeah. So as you can see, I have already written the program regarding the recursion. So it's very simple, and for the start, when some students are new inside that, and they're trying to understand. So something, first they should learn about the Java actually, because I'm not going to explain here the Java language. I'm just solving this approach, Fibonacci approach, using the recursion technique in Java language. Okay, currently, because the video will be lengthy if I will explain the Java as well. Okay, so in next video, I will just come with some topics with Java as well, and basic and advanced. Okay, yeah. So here what we have created, this method, Fibonacci method, as you can see, Fibonacci method, and we are just applied the mean base condition. So you have to remember the recursion step inside the recursion logic. We should have the mean base condition. If you are not applying the base condition, your recursion will have the problem, will cause the problem. It can easily fill your stack memory, and it will throw a stack overflow exception. Okay, yeah. So let's let me explain this. Yeah. So here actually we already have the taken the input: a is equal to 0, b is equal to 1, c is equal to 0. So we are passing those input from here, and n is nothing. N is where n is those input number which we will give at runtime for finding the Fibonacci series. Okay, yeah. So here we are checking, like suppose that n is equal to 5, and we already have the input 0 and 1. We already assigned there 0 and 1 for a and b. So if you see 0 plus 1 is equal to 1, after that we are assigning b. B means 1 inside the a, so a will be 1 and b will be 1 here. So we are printing here c, so 1 will print here, right? And now we are calling again for n minus 1. 5 minus 1 is equal to 4. For 4 it will call. Okay, and we are passing here a is equal to 1, b is equal to 1, c is equal to 1. So a plus b, 1 plus 1 is equal to 2. Okay, so here c value will be 2. So we will print here c 2, and now we are assigning a is equal to 1, b is equal to 2. So 1 2 2 we are passing for n is equal to 3, because 4 minus 1 3 previously we passed n is equal to 4. Okay, so now it will be n is equal to 3. Now it will go again. Now it will repeating the same step. A is equal to 1 plus 2. 1 plus 2 is equal to c value 3. So here 3 will print. Now it will assign here 1, 2 and 3. So here we are using the n minus 1, 3 minus 1, 2. Now we'll go again the 2. So 2 is also greater than 0, if you see. So it will come inside that. And it will just add that particular. 3 plus 2 is equal to 5. So C will be 5, right? 5 here. So C, 5 will print. And here we are assigning inside that. 5 will go inside 5 will go inside b, and a will hold the 3, actually, because b value is now 3 and b value is now 5 here, but b value previously it was 3, so a will be 3 and b will be 5. So c will print here 5. So here we are passing 3 5 5 for n is equal to 1. Previously we passed is equal to n is equal to 2. So to 2 minus 1 is equal to 1. So again 1 for 1 3 5 5. So 3 plus 5 is equal to 8, so it will print 8. Now n is equal to 1, 1 is greater than 0, right? So it will come inside that definitely. Now we have a is equal to b, b value here 5, right? C value here 8, right? So 5 8 5 8, and then this is c 8, and 1 minus 1 0. Now it will come again here, but here this condition will stop those compiler. Okay, and compiler will not go inside that. Runtime process will not happen inside that, and it will come outside from the if condition, because this base condition is false here. N is 0 now, and 0 is not greater than 0, so it will not run. So here it will be your output. So first it will print 0 1, then it will print 1 2 3 5 8. So this is your particular Fibonacci series. So let's run this. So here we are printing for 5. So if you see, perfect. 0 1 1 2 3 5 8. That's what we are just executing. 0 1 1 1 1 2 3 5 8. We are printing. Okay, perfect. So let's calculate the time complexity of this program. So time complexity of this approach will be, suppose that t here we are calculating like that, f5 is equal to f4 plus f3, right? That, so we can write these things. Tn is equal to tn minus 1 plus tn minus 2. Okay, so here we are calculating. So what is happening here? What is happening here, suppose that there is a root f5 tree. So tree will be broken, a tree node will be broken inside two nodes, 4 and 3. Okay, so like that tree node is 5, the root node is 5. So 5 is broken, 4 and 3, then 4 and 3 will broken, 4 broken, 3 and 2, 3 broken, 2 and 1, like that. And now 2 is broken, 1 and 0, 1 is broken, 1 and 0, and like that also here 3 is broken, 2 and 1, 2 is broken, 1 and 1, 1 is broken, 1 and 0. So like that it will consecutively. So the top node is 5, so our depth will become 5 4 3 2 1. So there are 2 to power 5 node will be available. So those node, for solving those nodes, the time complexity will be 2 to power 5 here. So it will become 32. But again, this will be very large when your n value is something like thousands, million or billion or something like that. So it will be very large. So in that case, your recursive approach will not be work like this program. So for that case, we have to use some cache, or we have to use some something, another approach to just reducing the optimizing the time complexity. Even the memory as well should not throw the memory exception, should not also time out, something like that. Okay, so that type of thing we will actually check in next lecture. I will come with that, some cache technique inside the Fibonacci. Yeah, so thank you. And one thing also, We haven't actually calculated the space complexity. Here we are using the same memory, actually same stack memory, so the space complexity will be v1. Okay. Yeah, thank you.